So we've talked about the calculus definition of a vertical asymptote. As x approaches some c, then the limit's going to be positive or negative infinity, or it could not exist. We also have a calculus definition of a horizontal asymptote, and it goes right along with our limits as we approach infinity. Because what a horizontal asymptote is it's talking about what your function is doing on the extreme ends. Remember in pre-calculus I told you that we can cross a horizontal asymptote in the middle of the function. A horizontal asymptote, it doesn't happen a lot, but sometimes a horizontal asymptote is crossed in the middle of a function. But on the ends, that's where it's headed. It's talking about the end behavior. So if the limit as we approach infinity of a function is c, or as we approach negative infinity is c, then y equals c is your horizontal asymptote. I have seen them ask questions, those like which of the following are true kind of questions. I've seen those on the AP exam before, and you've got to understand that a horizontal asymptote can be described using limits as they approach infinity. Okay, this principle of dominance is on the worksheet. It's what we've been using, okay? If it's bigger on the bottom, then your limit is 0. If it's the same, then you take the ratio of the leading coefficients. If the exponent is bigger on the top, then your limit is positive or negative infinity. You've got to figure out which one it is by using your exponent rules. Negative number cubed is negative. A negative number squared is positive. All right, so there's your principle of dominance. Here is an AP style question. Well, this is really just a pre-calculus question, but I think I found it in the calculus book. What is the horizontal asymptote of the graph of this function? So pause the video. Don't use your calculator. Do not use your calculator. Look at that function to try and figure out what the horizontal asymptote is, and then come back for the answer. Guess what? The answer is B. Some of you probably chose C, 1/4, because you were just looking at what's in front. But you've got to pay attention to the details. They love to do this. You've got to pay attention to it's the highest powered in the numerator and in the denominator. So the bottom's not in standard form. You got to go looking for the highest power. So it's x cubed over negative 5x cubed. So it is negative 1/5. Or you may have said, if it wasn't C, you may have said that it didn't have one because the degree in the numerator was greater than the degree in the denominator, but you forgot to look at the entire denominator. Okay, so be careful with stuff like that. Let's talk really quickly about sketching functions if they give us some limits. I also have a handout for this if you want to print it out or you want to come get a copy, but really you just need some graph paper. So they tell us all this stuff. So let's break it down. Let's start with that first one. The limit as x approaches 0 of our function is infinity. So that doesn't say right or left. So if it approaches infinity, that means on both sides of 0, I need to be going towards positive infinity. So that's A. All right. The limit as we approach 2 from the right is positive infinity. So 2 from the right, I'm going to positive infinity. I'm going to connect all the pieces here in a minute, but I need to make sure that I get what they've given me. 2 from the left is 1. Okay, 2 from the left is 1. So I'm going to put a hole there. And it's from the left, so I'm going to extend my function here to the left just a little bit until I see if anything else is going on there. As we approach positive infinity, our function is going to 2. Okay, so I'm just going to put this over here because I don't know whether I need to be coming from the top or the bottom. So I'm just going to put that there right now. As we go to negative infinity, it's 1. So same thing over here. I'm just going to put a line at 1. And it says f is continuous everywhere except at 0. Okay, well, I was expecting that at 0. Since my limits were infinite, I thought 0 is a vertical asymptote. Okay, that is a vertical asymptote right there. And at 2, which I kind of expected that because my left and right-handed limits did not agree. But it's continuous everywhere else. So that means that we've got to be able to connect all these pieces to make a continuous function. So I'm going to come over here and erase this just a little bit because this is all the detail. I'm not going to add any extra detail. I'm just going to connect my pieces. So since I've got this right here, I'm going to extend that. So that means I'm coming at 1 from the top. So when you're doing this, you need to make it clear that you're headed towards y equals 1, and you need to make this a smooth curve right here. Okay, it looks like I can just connect these two pieces of my graph right here. Okay, so I'm good. Left to right, make sure that I'm a function. I'm not failing the vertical line test here. Move left to right. I'm good. I don't have a value at 0 because I'm not continuous at 0. From 0 to 2, I'm good. And then I'm going to connect this piece, this right-handed limit of 2. I'm going to come down here, and as I go towards infinity, I'm leveling off at y equals positive 2. Okay, so that is the function that's described by those limits. Now, your picture doesn't have to be exactly like mine. That's just kind of the bare bones minimum of this function. Okay, let's look at another. Okay, so the limit as t approaches infinity of f of t is 2. So again, I'm going to put me a line out here. I don't know whether I need to be above that or below that. As we approach negative infinity, it's 0. So I'm headed towards the x-axis on the left side. 0 from the right is positive infinity. Okay, 0 from the right is positive infinity. 0 from the left is negative infinity. The limit as we approach 4 is 3. And right below that, they say f of 4 is 6. So f of 4 equals 6. I'm going to plot that point. 1, 2, 3, 4, 2, 4, 6. I'm going to plot that point. But my limit as I approach 4 is 3. So since I've got that point, I got to have a hole there or something. Now, they didn't tell us anything else. So our assumption needs to be that this is continuous everywhere else. All right, so I need to connect these pieces. So I'm going to take this part below 0 because my left-handed limit as we're approaching 0 is negative infinity. So that means as we're going to the left, I need to be coming up to 0. Then I'm going to connect my right-handed limit as we approach 0 to my hole. And then my hole is going to approach 2. As we go to infinity. That is what is described. Okay, I passed the vertical line test, move left to right with a vertical line. Make sure you don't touch 2 places at one time. We're good for this one. That's the biggest thing that I've had issues with in the past, is that when you go to connect all the pieces, you want to try and connect them all to each other. They don't always all connect. We have a vertical asymptote at 0. Those pieces aren't supposed to connect. There's supposed to be a gap right there. Okay? So work on the worksheet. That has plenty of examples there that you need to sketch. Now, my enter key, your pictures do not have to look exactly like mine. They should look pretty close, but they don't have to look exactly like mine. But you got to make sure that you have the properties described. If you want to ask me about one, feel free to send me a picture, and I'll shoot you a text back whether or not it satisfies those properties or not. Okay? Good luck.